Hello friends, welcome back to my channel Quality Magnify India. Myself Deepak Kumar Shamal. Welcome all the subscribers and viewers to my channel. Friends, hope you are watching all the previous videos regarding to APA 653. We are continuing APA 653 training courses in which we have completed already APA 650 and now continuing APA 653. As I told you, after completing APA 653 course, I will continue the related course which will come in the examination of APA 653 like APA 571, 577, ASME section 5, section 9, APA 651, APA 652. But as I told you, the most of the questions we found from APA 650 and 653. Around 20 to 25 questions from APA 650 and around 90 to 95 questions from APA 653. So we have completed few chapters from APA 653. Today we'll cover chapter 5, 6, 7 and 8. Rest of the chapters and annexures will complete in next two parts. What I've decided, I will go with some question reviews for APA 650 and APA 653. Those question reviews will take few slides, and by reviewing those questions, in addition to watching those videos, will definitely give you a better possibility, a better chance to clear the exam. So let's start APA 653 training course part 7. So we completed chapter 4 and this is chapter 5. In chapter 5, I am expecting 3 to 4 questions, 1 or 2 questions open book and 1 or 2 questions closed book. So chapter 5, it states brittle fracture considerations. You know very well, we have talked about the impact strength, and I have explained in chapter 4 what is impact strength, why it is required, how it will be done. Okay. For bottom, roof, for bottom, cell plate, what are the impact requirements? Okay. So here we'll do the brittle fracture study, how the brittle fracture is considered, at what temperature, at what thickness, okay, the brittle fracture will be considered. We'll see a graph after 1 or 2 slides, okay, and that is the open book questions, exception curve, okay. So let's start brittle fracture considerations. In all reported incident of tank failure due to brittle fracture, failure occurred either shortly after erection during the hydrostatic testing or on the first feeling of the cold weather after a change of lower temperature service or after a repair alternation. This experience shows that once the tank was demonstrated, the ability of withstand to combined effect of maximum liquid level, high stress and lowest operating temperature without failing, the risk of failure due to the brittle fracture with consideration service is minimal. What is this? Okay, what is the gist of the story? We have read in chapter 4 and I have explained to you how brittle fracture is impacted. Brittle fracture is usually for the impact strength. Impact strength is considerable low when the temperature is low. So if the tank is installed in a colder region part of the world where the temperature is very low, or the product used in the tank that is a considerable low temperature, then there is a high chance of brittle fracture. This brittle fracture happened due to lower the impact strength. So that's why what we do, impact testing is required. What are the requirement of impact testing? How we need to do the impact testing? How many samples are used? Okay, how the minimum value, how the average value is calculated? Those we already read in the last chapters. If you didn't saw those parts, please do visit those parts because each and every part is interlinked with each other. Any change in service must be evaluated to determine if it is increased the risk of failure due to brittle fractures. If we are using some service and we are changing the service to another one liquid which is considerably low level of temperature, then the failure for brittle fracture need to be considered, need to be studied. Okay, there are some of the steps here where it mentioned how the likelihood of repair and alternation, such as original hydrostatic test not meeting the requirement of the standards and deterioration of the tank since original hydrostatic test is done. Because what happened in the tank when we do the complete construction, then to find out if the liquid which we are using, whether it will the service liquid which we are using, we have to do the hydro test. Okay, if the hydro test is pass, then we can consider it the tank is acceptable. Okay, and that aspect we can find it acceptable. But in any case, if the service liquid is changed, okay, or the tank is relocated, we have written there reconstruction and relocation. If it is relocated, then based on that area temperature, okay, we have to reconsider all those things. Okay, hydrostatic testing, as I told you, hydrostatic testing demonstrate fitness for continued service with minimum risk of failure due to brittle fracture. So the aspect is hydrostatic testing. We need to do this one in order to find out the fitness of continued service with minimum risk of failure due to brittle fracture, provided that all governing requirements for repair, alternation, reconstruction or change in service are in accordance with the standard. So these are usually closed book exams. Okay. Step 4, what we do? There are few steps to find out what are the requirement for brittle fractures. Okay, if a tank cell thickness is no longer than ½ inch, if it's not more than ½ inch, then the risk of failure due to brittle fracture is minimum. Okay, that is a closed book questions. If the tank cell thickness is no greater than ½ inch, ½ inch means 12.5. Okay, the risk of failure due to brittle fracture is minimum. What is another one risk? This step 5, no known tank failure due to brittle fracture have occurred at cell metal temperature at 60 degree F, 60 degree Fahrenheit or above. So above 60, lower, as I told you in the beginning, lower the temperature, brittle fracture chance is higher. Okay, so that's what it is saying, 60 degree F or above, so the chance of brittle fracture is less. There is a graph, as I told, open book question. In the next slide it will come. So industry experience and laboratory tests have shown that membrane stress in tank cell plate at least 70 ksi is required to cause failure due to brittle fracture. So that is another one factor. So these are the factors. 0.5 inch, no greater than 0.5 inch, the risk of failure due to brittle fracture is minimum, and 60 degree F or above is less brittle fracture. And here the cell plate of at least 7 ksi is required to cause failure due to brittle fracture. So these are closed book questions. Usually it comes. Step 9. An evaluation can be performed to establish a safe operation envelope for a tank based on the operation history. This evaluation shall be based on the most severe combination of temperature and liquid level experienced by the tank during its life. It is a closed book exam. Okay, these are the cause. Restricted the liquid level, restrict the minimum metal temperature, change the service up to a stored product with a lower specific gravity. Okay, the specific gravity, I told you specific gravity of water is 1. Okay, lesser the specific gravity, lighter the product will be. That's why the oil float on water, because its specific gravity is lesser than water. Okay, so these are the steps we consider during brittle fracture. So you will expect one closed book question from this one and one open book in the next slide. Okay, what is the open book exam? This is the open book exam. Exception curve for tank constructed from carbon steel of unknown material specifications. If you see the curve, it is a simple curve. In the x-axis, it is showing cell thickness. In the y-axis, it is showing cell metal temperature. In exam, they will ask you a question. Let's say a material, it is 0.0, 0.5 inch. Okay, let's say 0.2 inch. Okay, this point. It will ask a question 0.2 inch with 50 degree F. Okay, 50 degree F. Is it need additional assessment? Then you can say no, it is not required. Simple question, simple answer. It is very easy to score. Okay. If it is asking, let's say 0.5, 0.6, 0.7, 0.8, 0.8 inch, okay, and the temperature is 60 degree. We read it just last slide. Is it additional assessment is required? No. Okay. If it is saying 1 inch and the temperature is 30 degree F, is it required? Yes, it is required. Okay. So this curve is a must open book question. You have to remember this. Exception curve for tank constructed from carbon steel. So that's all for chapter 5. You will get one closed book or max 2 closed book and one open book exam. Section 6, inspection. You will get 5 to 7 questions, okay, out of which 2 to 3 questions is open book, and 2 to 3 questions are closed book. As we do the inspection in APA 650, similar we have to do the inspection in APA 653, okay. So for the inspection of section 6, there it is the new construction tank, that's why the interval was not given. Here it is a in-service inspection, that's why the interval is given. External inspection, what are the intervals? Internal inspection, what are the intervals? So both you will get 2 to 3 questions as open book and 2 to 3 questions as closed book. So we make it as simple. Roof plate inspection for in-service tank APA 653 as per APA 653 either by the inspector or examiner. This is important. Usually they ask in the exam who will do the examinations. Inspector, examiner, inspector and examiner, inspector or examiner. So they play with and or. So that's why I told you from the beginning, you have to note it down very carefully. And the maximum thickness allowed is 2.5 mm. Okay. Usually for the roof plate, the maximum in-service inspection is 2.5 mm. If it is less than that, then a repair is needed. Cell inspection there is 3 types. You have to remember there is 3 types of cell inspection. Okay. First, routine in-service inspection. Routine in-service inspection we have to do every month and will be done by the operator who is operating the tank. He will do the routine in-service inspection. Okay, so routine in-service inspection is every month and will be done by the operator. You have to remember this very carefully. As I told you, it is coming in the exam to make you confused. Who will do the routine in-service inspection? Inspector, examiner, inspector and examiner, operator. So it is done by the operator. Okay, external visual inspection. Routine in-service inspection by the operator and this will be done every month. External visual inspection will be done by the visual inspector. Okay, it is RCA by 4N or 5 year, whichever is less. You will ask me what is RCA? RCA means remaining corrosion allowance. I have already explained it in APA 653 beginning. What is remaining corrosion allowance? What is corrosion thickness? What is design thickness? Okay, what is ordered thickness? Those you have to remember, and there is must questions. Okay, design thickness, corroded thickness, ordered thickness. These you have to remember. So RCA by 4N. Now you will ask me what is N. N is the corrosion happened per year. Okay, let's say a plate thickness is 1 inch. Okay, a 1 inch plate. Okay, RCA remaining corrosion allowance. Let's say it was designed like the corroded thickness is 0.5 inch and 0.5 inch is the remaining corrosion allowance. Okay, let's say this remaining corrosion allowance is 0.5 inch. So when the tank was in service and till date, what is the difference? Okay, let's say when it was in service, at that time the plate thickness was 1 inch. Now we measure it and we found the plate thickness is 0.75 inch. And we measure after how many years? We measure in 5 years. Okay, we measure the thickness after 5 years and we found it is 0.75 inch. So 1 inch minus 0.75 inch divided by 5 is called N. Is it clear? 1 inch is the preliminary thickness of the cell plate. Present thickness is 0.75 inch. preliminary and present, the time is 5 years. So I minus the T previous, okay, T previous minus T actual divided by number of years. The corrosion per year is called N. Okay, remaining corrosion allowance is point. I told it is let's say the minimum corroded allowance is 0.5. So remaining how much? Now 0.75 minus 0.5. That is called RCA, remaining corrosion allowance. So that divided by N, okay, you will find some years. Let's say 0.75 minus 0.5, it is coming 0.25, okay. So 0.25 divided by N, as I told, N, okay. 0.25 divided by 5, we did it 0.5, okay. So 0.25 divided by N, how much it will come, okay, in number of years or 5 years, whichever is less. That is called external visual inspection. You will get one open book question for this one. Okay, it is simple calculation. RCA is remaining corrosion allowance. He will give you a blah 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 values. Okay, a tank was installed in 2010 with 1 inch cell thickness. Then in 2015 the cell thickness was again measured and found 0.75 inch. When will be the next external visual inspection will be done? So you have to do it. RCA by 4N or 5 year, whichever it is. Do RCA by 4N and find the years, and then find whichever is less, whether it is less or 5 year is less, whichever is less, you have to put the date. Okay. Similar, if you are going for UT measurement inspection. Okay. If you are doing UT measurement, there is two things. One, very clear, if corrosion not known, it is 5 years, straight 5 years. If corrosion is not known. If corrosion is known, then RCA by 2N or 15 years. There it is RCA by 4N for external visual inspection. For UT, it is RCA by 2N. Okay, that there it is RCA by 4N. Here it is RCA by 2N or 15 years, whichever is less. There it is 5 years, here it is 15 years. So is it clear? Here it is 15 years for UT. Okay, 15 years, whichever is less. So this is must. This is must, as I told you. There is a question in the open book. It will come. Okay. For bottom plate inspection, the maximum allowed is 2.3 mm. So this what I explained now. In next slides, it is only written in the book. So this is the gist what I have explained here. Okay. So the interval between the inspection of a tank, both internal and external, there is two part, as I told, internal and external. External inspection now we are reading. Internal, there is 10, 20, 30 rule. I will tell you in the next slides. So here you will get 1 or 2 questions. Okay. So what is saying, the interval between inspection of a tank shall be determined by its service history unless special reasons indicated that an earlier inspection must be made.
Sorry. Sorry.
So jurisdictional regulations in some cases control the frequency and interval of the inspection. Jurisdictional regulations means the local authority regulations. Okay, as I told in the previous, if API 650 and 653 were using, then we have to give API 653 as the preference, and when API 653 and local jurisdiction regulations are used, if the local jurisdiction rules are more stringent than API 653, then we have to go for local jurisdiction regulations. Okay. So what is routine in-service inspection? The external condition of the tank shall be monitored by close visual inspection from ground on a routine basis. This inspection may be done by owner or operator personnel and can be done by other than authorized inspector as described in 3.4. Okay. The routine in-service inspection shall include visual inspection of the tank exterior surface. As I explained earlier in the last slide, Routine in-service inspection shall include a visual inspection only, no instrumental inspection. Visual inspection for tank external surfaces. If there is any leak, if there is any crack, if there is any corrosion, that we can see by visually. Evidence of leak, cell distortion, signs of settlement, corrosion, all these things I can find out by a normal visual inspection, and it can be done by the operator. External inspection, as I told you, it is the summarize what I told on the last slide. External inspection, all tanks shall have given a visual external inspection by an authorized inspector. The inspection shall be called the external inspection and must be conducted at least every 5 years or RCA by 4N, as I told you. Okay, it is only the summary what I told in the previous 2 slides, where RCA is the difference between the measured cell thickness and the minimum required thickness in mils. Okay, mils means 1000 of inch, and N is the cell corrosion rate in mils per year. That I told you. Okay, whichever is less. This less word is important. Okay, so it is RCA by 4N or 5 year. 5 year or RCA by 4N, whichever is less. The insulated tank need to have insulation removed only to the extent necessary to determine the condition of the exterior wall of the tank. Tank grounding system component such as stones and mechanical connections cables shall be visually checked. So what happened for the ultrasonic? I told you there is 2 things. If the corrosion rate is not known, then when the corrosion rate is not known, this is very important, not known, then maximum interval shall be 5 years. If it is not known, 5 years. If it is known, then maximum interval shall be smaller of or less. Smaller means less of RCA by 2N or 15 years. That's what it is saying. RCA by 2N or 15 years. Cathodic protection survey 651. Okay, that will read. There is a chapter for 651. You will get 4 to 6 questions from 651 and 652. Lining also. Okay, we will read 651 and 652. So where exterior tank bottom corrosion is controlled by cathodic protection, cathodic survey for the system shall be conducted in accordance to 651. Internal inspections. Okay, how will do so those are external inspections already finished. And what are the criteria we already got. Remember, for internal inspection there is open book questions usually they ask. Okay, there is a 10, 20, 30 rule that is also usually asked. So what are these? Okay, so what is saying, ensure the bottom is not severely corroded and leaking. For internal inspection, check the tank bottom is not corroded and leaking. Gather the data necessary for the minimum bottom and cell thickness assessments. Identify and evaluate any tank bottom settlements. Okay, so what are the internal inspections? Inspection intervals. How we do the inspection intervals? This table is a open book question and it will come. Okay, so for existing tank owner and operator shall review the internal inspection interval and be compliant with the section within 5 years from the date of first publication of 653. This is not important. The important is 64211. The interval from initial service date until the first internal inspection shall not exceed 10 years. That means 10 years is the minimum to do a internal inspections. But in cases, the years can be further go higher. What are the cases? Okay, tanks as one or more of the leak prevention, detection, corrosion mitigation and containment safeguards listed in table 6.1. This is the tank safeguards. Okay, internal safeguards. So credits so which are cumulative. The initial internal inspection interval shall not exceed 20 years. That means if it is 10 years and it is tank is safeguarded, then it can go up to 20 years. Okay, without a release prevention barrier. Release prevention barrier means there is something given, some additional protection is given, then we call it release prevention barriers. So for release prevention barriers, if it is there, then we can exceed to 20 years also. So in some cases it can go up to 30 years without release prevention barrier. So the max is 30 years. So it is a 10, 20 and 30. The limit for table 4.4, the bottom plate requirement do not apply when establishing the initial internal inspection interval in accordance to section 64211 or and table 611. There is a 4.1, if you remember, we read it about the bottom plate thickness, minimum how much required. But now in this slide we will not read this one. In this slide, what you will do, there is an open book question as I told you. The minimum is 10 years, that you have to remember. First thing. Second thing, if any release prevention barrier is there, then it will be 20 years. And if there is no release prevention, it will be 30 years. That's why I told 10, 20 and 30. Now, how to calculate when we will do the release internal inspection? So 10 years is must, you got the 10 years. For table 6.1, it is saying if a fiberglass reinforcement lining is there, then add 5 years more. If installation of an internal thin film coating is there, then add 2 years more. If cathodic protection of the soil side of the tank bottom installed and maintained and inspected as per RPI 651, then add 5 years more. If prevention barriers is installed as per API 650 NXI, then add 10 years more. Initial bottom thickness greater than 0.25 inch, then calculate accordingly and add as many years. After that it will be done after calculations. If bottom constructed from stainless steel material that meets the requirement of API 650, then add 10 more years. Okay. Corrosion rate to be 15 mils per year or as determined from NXH for similar services. So there is usually a open book question they ask. Okay, for example, here there is a question they have given here. Okay, so what is the question they given? The maximum initial internal inspection interval for 5/16 inch thick bottom. The bottom thickness is 5/16 inch. Okay, 5/16 inch is how much? 0.3125. You divide 5 by 16, you will get 0.3125 inch. That has a release prevention barrier. Release prevention barrier, it has a release prevention barrier. That means we have to add 10 years. And a fiberglass reinforcing lining. Fiberglass reinforcing lining, how much it is coming? 5 years. So 10 years we have to add for release prevention barrier. 5 years we have to add for fiberglass, 15 years. Initially we have to give 10 years. Then what is the thickness is telling? 5/16 inch. 5/16 inch means 0.3125. And what we read here? Above 0.25 inch. So 5/16 inch minus 0.25 inch. And what is the corrosion rate? 15 mil per year. 15 mils, as I told, 1 mils is 1 inch per is 1000 mils. So 15 mils means 15 by 1000 inch. 0.015 inch. So 0.3125 minus 0.25 divided by 0.0125. So it is coming 4.2 years. So we have to add additional 4.2 years. So this is the total. Okay. 10 plus 20, 25 and 4.2, 29.2 years. So this type of open book question you will get in per table 6.1, okay, for the external inspection. So you have to always remember what do we mean by release prevention barrier, with release prevention barrier and without release prevention barrier. As an alternative to establishing the initial interval in accordance to 6.421 and table 6.1, the initial internal inspection date and a reassessment can be established by using RBI assessment for 6.222. Okay, so this is the key thing. This assessment may be established an internal inspection interval exceeding 10 years but not exceeding 20 years for tank without a release prevention barrier or 30 years for tanks with release prevention barrier except as follows. Alternative to internal inspection to determine bottom thickness, this is the table. Okay, whole gist, this paragraph gist is describing this table. This already we read in our last slide. Please check the slide and you will find out what is the tank bottom or foundation design level and what will be the minimum thickness it is required. Records. For doing the inspections, whatever the records we have to use. This is a closed book exam. Usually 3 types of record we are using: construction record, inspection history, repair and alternation history. So in construction record, we may maintain nameplate information, drawing, specification, construction completion report and any result of material test. Inspection report, we have to maintain the record of all examinations and test. And repair and alternation history, include all data accumulated on a tank from the time of its construction with regard to repair, alternation, replacement and repair changes. Usually this is a closed book exam and you have to remember it. It's slightly tricky when it comes in the exam. Okay. So these are the recommendations for the reports, how we have to keep the reports, and these are the recommendations for the NDE. This is not so important, but for your information, I have put it here and you can make a note of that. Materials, you will get one question from materials. Okay, what new materials? All new materials used for repair, alternation and reconstruction shall conform to current applicable standards. So as you know, I have already told you what is current applicable standard and what is as-built standards. Hope you remember that. Cell and bottom plate welded to cell. All cell plate material and bottom plate welded to cell shall be identified. That means traceability. Traceability is required. Material identification by original contract drawing, API nameplates and other suitable documentation do not require further identification. Material not identified shall be tested and identified by the requirement as outlined in 7312. Okay. There is another one requirement for the chemical analysis and mechanical test is required for each individual plate for which adequate identification does not exist. This is a open book question. Then what we'll do, we have to do additional analysis and mechanical test as per ASTM A6 and ASTM A370 including JARPI V-notch test. So we'll get one question from new materials, chapter 7, section 7. And section 8, design consideration for new construction tank, also one question will come. All new joint shall be butt welded joint with complete penetration and complete fusion. Okay, and cell requires cell design. This 180 days is important. Thickness to be used for the each cell course when checking cell tank design shall be based on measurement taken within 180 days prior to the relocation. This paragraph is important, 844. If a corrosion allowance is required for the reconstruction tank, the required corrosion allowance shall be deducted from the actual thickness before calculating the maximum liquid level. Okay. Seismic design. What is seismic design, friends? Seismic design is earthquakes, considering earthquakes. Okay. Tanks that will constructed shall be checked for seismic stability based on the rules of current applicable standards using the dimension and thickness of reconstruction tanks. So that's all up to section 8. Then we'll go for section 9, which is the most important, and rest of the part we'll cover in next two parts. Okay, and after that we'll complete APA 653, and further we'll continue with the related topics which will come for APA 653. Many thanks, friends, for watching my videos. I hope you are getting a lot of benefit from the videos by taking notes and preparing for APA 653. Many thanks, friends, for watching my video, and thanks for giving your time to watch the video. Have a good day.